To become something that mathematics can deal with, a motif must be drawn as a picture. There are times when we get stuck while solving a problem. What usually troubles us then is not calculation. What exactly is connected to what? Where could the clue be hiding? These questions, in everyday problems and throughout the history of mathematics that has lasted thousands of years, have kept appearing in the same form. The reason for getting stuck has always been similar. It was not calculation, but relationships. That is why we sense invisible relationships through the connections between things that look alike. We call this process analogy. Analogy is not a skill unique to mathematics, but a force that pushes thinking forward in every field. In an age overflowing with information, what we need is not so much the ability to accumulate more knowledge, but a sense for organizing scattered pieces and recognizing similarity. The moment that sense switches on, thinking makes a leap. That connection is where creative thinking begins. However, analogy does not happen simply because we decide to make it happen. The more a person has seen and heard, and the more places a person has visited, the more naturally analogy arises. The same is true for a mathematics problem we see for the first time. When a teacher gives one small clue, a path suddenly opens. It is like failing to find a light switch in a dark room, then hearing the words, 2 steps to the right from the wall, and the light switches on. That 2 steps in mathematics is often a picture. This is why many researchers say that visual representations are such a powerful help. When we rebuild a problem as a picture, the knowledge that was scattered in our mind begins to link together. Even complicated formulas, in one way or another, are connected to pictures. Put another way, this is what it means. If we can express a motif as a picture, from that moment on, it becomes something that mathematics can deal with. These days, mathematics uses letters like X and Y. Pictures are gone. We might say this, but humanity first stored its thoughts through pictures. Cave paintings were not decoration, but the first records of trying to understand the world. And great mathematicians do the same thing today. They create formulas while looking at pictures, and imagine pictures while looking at formulas. When Descartes described conic sections using coordinates and equations, it was, in the end, an event of translating pictures into language. When Andrew Wiles worked through Fermat's last theorem, which had remained unsolved for 350 years, the pictorial world of elliptic curves became an essential foundation. When we see a ball flying, we think of a parabola, and when we see that curve, we think of an equation again. Moving back and forth between pictures and formulas, translating, this round trip is the breadth of mathematics. A picture is not just a simple way to make things look good. It is a process of bringing natural phenomena and motifs onto the stage of mathematics. It is also the fastest path to turning the complexity in front of our eyes into relationships. For example, geometry draws points, lines, and planes to uncover their properties. A function sets causes and results on a graph, then finds the formula that matches that graph. A set with just one Venn diagram organizes inclusion, intersection, and union at a glance. When a road network is simplified into lines, problems like the shortest path or one-stroke drawing appear, and even the complex connection structures of artificial intelligence are ultimately read as a picture called a graph. Also, it is not only visible things that can be drawn. Sound can be drawn as waves, smell as molecular structures, and electromagnetic waves can be turned into pictures of vibration and frequency. The moment something invisible appears as lines and points, we become able to compare it, predict it, and work with it. Come to think about it, life is similar. Complicated emotions and relationships, when kept only in the mind, become even more tangled. When we put them down on paper, who is connected to who and where things are blocked can start to become clear. On days when the world feels too complicated, picking up a pencil before reaching for a formula might be faster. The moment we draw a single line, relationships begin to shape.